Got your camera ready to roll? Time to focus on the old circle. Area of a circle. I gave that to you on today's Wednesday, Monday. Little refresh here. Oh boy, I know I just didn't hear that come from the back. I know I didn't hear 2 pi r. There it is. Can you go first one of the day? 24. Yep. It's going to be a good day. Here we go. Pi r's. Sorry, area of a circle. How do you not have a 24? All right. I don't care. Just out of spite. Here we go. 19. Thank you. Pi r squared. I wasted all that time for a pi r squared. Yep. Don't really have the time to waste just to say, here's a circle, what's the area? So let's get to a different type of one. Area is 95 square centimeters. What must have been the radius? All right, so we have A equals pi r squared. Area I told you was 95. We can plug that in. Now I'm interested to see what's your next move to get r by itself. What's your next move to get r by itself? First up, here we go. I'm not. Okay, here we go. 8. What's your next move? Ooh, I don't think we're ready for that yet. We are not ready for the square root because I do not know what the square root of pi r squared is. I know what the square root of r squared is, but not pi r squared.
Divide both sides by pi.
Divide both sides by pi. Got it. Yep. And you don't have to write out the full decimal. You can just leave it as 95 over pi. So you don't, I know your wrist might hurt from writing all that out. Then Colin on both sides to get r by itself. Find the square root of both sides. Square root, square root. And as you guys can see, I didn't put any rounding directions on this one, so it looks like we're going full calculator display as usual. So 5.499039842. What are we looking at as far as units go? Centimeters, should I have it square centimeters? Nope, let's not be silly. Okay. The concern today is not the area of a circle, it's the part of the circle. Okay, part of the circle. Looks like the piece of pizza, or there you go, huh? 30? There you go, 30, right up your alley today. Looks like a piece of pizza or piece of pie. Okay, part of the area, that's called a sector. Sector. Okay, part of the area. 2 different ways we could find it. Because as you now know at this point in the year, angle O could be in degrees or it could be in radians. So we have 2 different formulas. And again, this is the same thing as when we found the length of an arc. Do you need to memorize both? No, you don't. Can you? Yes. But if you memorize just one of them, be able to do what? Convert back and forth from radians to degrees. All right? Degree formula. Did anybody remember length of an arc formula? Measure of the arc over. All right, hold on, champs. measure over 360, and then for length of the arc, we multiplied it by what? The circumference, because it was part of the circumference. But now we're finding a sector which is part of the, not the circumference anymore, it's part of the what? Area. So we're not going to multiply it by pi d, we're going to multiply it by pi r squared. That's if your angle is in degrees. And if it's in radians, if this central angle right here is in radians, we can use the following. 1/2 r squared theta. R is the radius length. Theta is theta. Angle in radians. Okay, if it's in radians. Again, you have to pick what you're comfortable with. I am not going to force something down your throat here. All right, you have to pick what you're going to be comfortable with. Ready to go. And then we get to some of my favorite problems of the year. Here we go. Example 2. Mine are kind of flip-flop. Sorry, mine's over on the right here. What's the area of a sector of a circle with a radius of 8 and a central angle that measures 60 degrees? What's the angle in? Degrees. You guys that want to convert, go ahead, but since it's in degrees already, I'm going to use the degree formula to find the area of this sector. If the central angle is 60, what's my arc measure? Here we go. Boom, 21. Arc measure, also 60. Over 360 times, let me know what I'm going to multiply this bad boy by. 9, what do you want to multiply it by? Sector formula I just gave you. Pi times 64, 8 squared, that's where she's getting it, just getting ahead of the game. And look at your answers. Everyone see all the multiple choices? They're all in terms of pi. So leave the pi, don't touch the button on the calc. I will need you to do 60 over 360 times 64 though, and just leave pi in your answer. Some of you may be getting a decimal answer. Do we need to cover how to turn that back into a fraction? Okay, no problem. I wish they wouldn't have done this stuff in the old middle school, but it's fine. So everyone's doing 60 divided by 360, and you're getting that, then multiplying it by 64. How do I turn that back into a fraction? You got a math button on the left-hand side. Hit your math button. First option says change whatever you have back to a fraction, number 1. And it will do so and tell you 32 over 3. Questions there? Ask now, because that was just a basic one. Plug and chug. It's only going to get crazier from here, as you know. Yes, Maggie. You got the decimal? So hit your math button on the left-hand side, and then the first option should be change it to a fraction. So you got 10.666, and it won't change it back? Really? Okay, try this instead then. You have a fraction template, alpha y equals, right? So use that, do 60 over 360, and then off to the side times 64 using a fraction template. Because usually when you use a fraction template, your calculator will leave it in fraction form for you. Good? Okay, so just use your template. Anything else? Any other calculator issues? We all good? All right, here. We got some silly kids here. We got Amy, Beth, Carl, and Dex. Their one job was to find sector COB. So they got after it, and here is their work down below. Here is their work. But only 2 of them used the correct formula. We got to find which 2. So does everyone see the 108? Yes? So why don't we try to do it correctly for ourselves right now? How would I find sector COB? What's the measure of the arc? Here we go, 28, measure of the arc.
108.
Okay, so I would do 108 over 360. What's the radius? Oh, we don't, but you can name one, right? Name a radius.
Oh,
So I could do pi times, oh boy. Okay, we could use AO squared. Now, is that the only way to write it? Instead of AO, you could have used what? OB, OC, all right? So let's go through here. Amy, up first. Here's what Amy did. She took 3 over 10 and multiplied that by pi and then did BC squared. What's the issue with Amy's? What's the issue with Amy's? BC is not a radius, it's a chord. Amy, embarrassment. Beth, maybe short for Bethany, I don't know. 108 over 360, and we like that part, right? Times pi times the old OC squared. Beth? Welcome to honors, Beth. Nice job. Carl, maybe short for Carlton. Carlson, I don't know. 3 over 10 times pi. Now he took 1/2 of AB. What's AB? If you take half of that, you get the radius. Okay, here's my concern. Maybe somebody can help me. 3 over 10? Isn't that the same as 108 over 360, just simplified? Check your calculator if you don't believe me. All right, 108 over 360 is just 3 over 10 simplified. Carl, great job. Dex, maybe short for Dexter. I don't know. 108 over 360. We're good there. Times pi times 1/2 AB squared. Why is this not the same as Carl's? He's squaring the diameter, then taking 1/2. That's not the same as squaring the radius. Dex, embarrassment. So we're down to Beth and Carl. Great job. Everyone all good? We could play a real nasty game and substitute people's names from this class in here, but we'll avoid that right now. Moving on. Now a little different. I'll give you the sector area. I'll give you the area of the sector. You give me part of the formula now. So the area here you go, 12 pi square inches. What's the measure of angle AOC? What's that measure now of angle AOC? So does everyone see where right now I'm giving you the sector area? Can we make a class decision? Because does it specify degrees or radians? No. So your answer could be either one. So do we want to use the degree formula here or the radian formula? Okay, fine. We can use the degree. Ready? 12 pi, which is the area. What are we going to put on top here of this fraction over 360? It's the angle. What are we trying to find? The angle, x over 360. Everyone's all right with the x. That's the angle. Times. I'll ask somebody that. What do you want to finish this off with? Yeah, here we go. Oh, suspense. 9. Pi, 36 pi. Yep. R squared. All right, kids. Algebra champions in the room. How are we going to get x by itself? Can we make this a little easier on the eyes? What's on both sides? Okay, eventually, when you move it over, they're going to be gone. I know, maybe a little easier to deal with. Up to you. What do you want to do on both sides here? What do we want to do on both sides? Multiply by 360? Okay, we can multiply by 360. So we'll have 36x here. Not too. What do we got over on the left side? 12 times 360? 300 and 12 times 36. 12 times 360. Divide by 36 on both sides. You're going to be looking at 120. Now, you did use this formula, so is this radians or degrees? Degrees if you're using this formula. Questions? Now, these might be my favorite type of problems coming up, where we just smash together figures and say, what do we got going on?
Oh my God!
Yay!
Anything else? Cube. Yeah, I don't know what to call it, so I'm calling it yesterday. We're definitely late in the year because now we can label off 14 of them. So, all right, here we go. Stars. Yep. Swing. I'll go both. Sure. I'll throw in the old both. Sure. Feeling crazy right now. I'll go both. Feeling crazy. Star. Curtains. Fades. Spins. Like the whole spin versus a pinwheel, which is they got smaller ones. Curl. Clock. Genies. Slide right. Slide left. Drop. Yesterday's one. Swing, I guess, both sides. Cubes. Shatters. Pinwheels. Okay, here we go. I feel like it's going to be one of them probably here. So, but we got curtains and Promethean Man. Ready? Finally. Finally. Whew. Okay. Whew. Correct. Yep. Okay. It is what it is. All right. Doesn't happen too often, as you know. So 2 in a row. Oof. All right, here we go. No. Here we go. All right, now we get, this is really starting today and all of class tomorrow where we have 2 figures mashed up into one. All right, and we have to find the area of the full thing. So first of all, let's discuss these 2 figures here are what? I have a trapezoid that I'll add to a half circle. All right, so let's go trapezoid formula, 1/2 height, B1 plus B2. Circle formula was not a sector, circle. Pi r squared. I always like, because we're just going to take half of it, just to remind myself, put the half in there now. Because I think if you say to yourself, oh, just do it at the end, I'll take half it at the end, you might forget about it. All right, going to need somebody to help me plug in for the trapezoid. Here you go, 26. 1/2. What's the height of this trapezoid? 4. How about the bases? 7 and 10. So that takes care of the trapezoid. So we're going to have 1/2 of 4 times 17. So you're coming up with the area of the trapezoid, hopefully as 34. And then how about the circle now? What's the radius of this half circle here? Oh, let's hear from 5. Radius of this half circle is 5. Look at that. So pi times 5 squared. 25, half of 25 will be 12 point. Why am I? Yeah, 25, 12.5 pi. If you chose to write out that full decimal, don't round it. Okay, don't round it. We're not ready to do the final answer yet. And then with the trapezoid and the circle, you're going to add those areas up. I'll give you guys a second to do that. Guys got off a packet page and a couple problems from the textbook. All right. 25, what do you have here? 73.3 square feet. Good job on the units. We okay putting those together? Okay, let's see if we can end it. This one's a tougher one. Actually, I am going to go through this one with you just because of it went back. And I got to do it again. Great. Okay. Okay. Rhombus. So the quadrilaterals are rhombus. Diagonals are 24 and 10. Find the area of the entire figure. So I already told you one part of the figure was a rhombus. What's the other part there? How many? So 3 circles? 3 semicircles. So in total, 1.5 circles. Dig the old rhombus formula out for me. 18, dig the old rhombus formula out. There you go. I gave you everything there. Gave you everything. 1/2, 24 times 10. $120. And then what about the 1.5 circles here? So I have 1.5 pi r squared. Ooh, whoa, hey, how about that? How about that radius? What? First of all, the side of the rhombus is the what of the circle? That's a diameter, so I do need to find that side. How? Well, 24 and 10, yesterday, what did the diagonals do in a rhombus? Bisected each other, and they were perpendicular. So we can say this is 12 from the 24. This is 5 from the 10. Perpendicular, I can do Pythagorean theorem with 12 and 5. That will not get you the radius. It will get you the diameter. What are we finding as the diameter? 13, which would mean the radius would be 6.5 squared. Hey, directions. How are we leaving our answer here? In terms of pi, nobody should be touching the pi button then. Should be 1.5 times 6.5 squared. And what do we end up with? 63.375 pi. Last piece here. To find the total area, we are going to add both. So 120 plus 63.375 pi. Ready? If our answer has to be in terms of pi, you got to have a pi in there, right? Do you think I combine 120 and the 63? Can I combine those two? No, so guess what? This is in terms of pi. That's as far as I can go in terms of pi. Oh, you better live this up tonight. Let me tell you. Live it up. Hopefully it's not a string of ones.